And I'm going to show you what you need to do once you're in there. All right, so first things first, I want my X and Y values to go up in terms of pi over 2. So you're going to go to the little wrench key in the top right corner. Now, you're going to type in from the y-axis, you want to go from negative 2 pi, so you can hit this key and hit the pi. So negative 2 pi to 2 pi, that's where we want our graph to be from. So you hit the wrench key, go to where it says y-axis, and fill in this part right here. So you want to go from negative 2 pi to 2 pi. And you're going to have to click the keyboard to get the pi. And then the step, so right here next to it says step. I want you to do steps of pi. So we're doing steps of pi. So here, I'll zoom it in a little bit so you can see it better. So I typed in from negative 2 pi to 2 pi, and then the step I wanted to go up in terms of pi. Because if you look, what happens to my x-axis? My x-axis now looks like our x-axis on our packet. Okay. You don't have to do anything to the y. I just want you to do it to the x-axis. The y's you can leave as is. Say one more time. Definitely radians. These are definitely in radians. So Desmos should automatically have it in radians, but if you did happen to switch it to degrees, make sure it's in radians. I also am zoomed in, so mine probably looks more zoomed in than yours. All right, so does everyone have their graph looking like mine? Anyone else need help? Or you guys good? So hit the wrench key where it says x-axis. You're going to do from negative 2 pi to 2 pi, and then next to it should say step. You're going to put a pi. So it looks like what's currently on my screen. All right, so what we're going to do is we're going to look at the effect of multiplying an A value to the front of the sine and cosine graphs. And they pretty much do the exact same thing. Okay? So, currently speaking, we have a normal cosine graph. So this graph right here is just good old cosine of x. All right? What I want you to do is I want you to graph this one right here. So put in your Desmos, y equals 3 times cosine of x. And what I want you to do is I want you to find all the points of which it hits negative 2 pi, negative 3 pi, negative pi over 2, 0, so on and so forth. So all the points in the axes and graph it on your paper. So I'll do this first one with you. So I'm going to type in y is equal to, you can literally just type in 3 times cosine of x. Now, notice how they mark everything for you. So if you zoom out a little bit, you want to go from negative 2 pi to 2 pi. So if you click all of these are all the points that you want to plot. Yes. Okay, so figure out all the y values for every value on the x-axis on your packet. So for example, negative 2 pi, what's the y value? 3. So that means I'll go to negative 2 pi, and then I'll go up to 3. Where is it at negative 3 pi over 2? What y value? 0. Where is it at negative pi? Negative 3. So right here. Where is it at negative pi over 2? Negative pi over 2, where's it at? 0. Good. Where is it at 0? So x equals 0. It's at 3. Where is it at pi over 2? 0. Pi. Negative 3. 3 pi over 2. 0. And 3. So if I graph this, it'll look something like this. Remember, it does have a curve to it. So make sure you put a little bit of a curve to it when you graph. So this would be 3 cosine of x. All right. You guys got that one graphed? So now go back to Desmos. And now do the next one. So you can literally just switch out this 3 for a negative 4. So switch out the 3 for a negative 4 in your function in Desmos. And you're going to do the same thing. You're going to tell me where they fall for each of their x values. So for negative 2 pi, where does it fall? Negative 4, so all the way down here. For negative 3 pi over 2, where does it fall? Are we doing it on the same one? Yep, on the same one. So if you like, you can either just label them or you can use different colors. My recommendation, different colors. So where is negative 3 pi over 2? Where does it fall? 0. What about pi? 4. 0. Then negative 4. Then 0. Then 4. Then 0. And negative 4. So if I draw it, it's going to look something like this. Now, typically you would put arrows on the ends of these. I'm just not, just to make it kind of look like the one that's graphed already. So this is -4 cosine of x. Okay? All right. Do the same thing for the next one. So put in 3/2 in place of the -4. All right, tell me what those points are. So start -2 pi. What's the y value? 1.5. So I'm going to go about halfway between 1 and 2. Then 0. Then -1.5. Then 0. Then 1.5. Then okay. Then good. So that graph looks something like this. So that is 3/2 cosine of x. And the last one, put in -2 cosine of x into your calculator. So what you got?
-2.
So -2, then,
2, 0,
then,
-2,
then,
0,
then,
2,
then,
0,
then.
-2.
Good. So these will look something like this. So here's my question. I'm going to plot the points of my original. So here's my parent function graph, the black one. That's cosine of x. So I'm just putting the points so you can see where they're at. So this is -2 cosine of x. So here's my question. Look at the original points for cosine of x. What's happening? What is that a value doing? Well, it's going back and forth, but for example, look at 0. So look right here specifically. What's the original point at? So for cosine of x, what's that original point at for 0? 0, 1. Where's it at for the green graph? 0, 1.5. Where's it at for the orange graph? 0, 3. Where's it at for the blue graph? 0, -2. Where about the purple graph? 0, -4. Let me ask you this. Look at the y values. Where have you seen those y values before for their respective graphs? It's the a value. So what the a value does is that it affects what we call the amplitude. Okay? That's altitude, sweet pea. So, we see this coefficient controls the height of the cosine curves and rises and falls above the x-axis. The absolute value is the given name for amplitude. Sound wave, so in terms of sound waves, the volume of the sound. So have you ever heard in terms of sound, like, like with rock and roll players, they have amps. That's short for amplitude. Okay? So amplifier, but it comes from the amplitude. So if you actually look at the sound waves, So if you actually look at the sound waves, the louder you play, the taller it's going to be. The softer you play, the lower it's going to be.
Or when they have like those foam things on the walls to keep the sound in, doesn't that have to do with it, like sound waves and everything?
Not quite. That's more so for acoustics. And acoustics, yeah. So now let's see if we can try and figure this out without the use of Desmos. But it's okay, because think about it. So what do you think I did to each of these points? So if the original was at 1, what did I multiply to it to get to the orange? So how did I go from 1 to 3? I multiplied by what? 3. Isn't that what the A value was? Mm-hmm. Same thing with the purple. I multiplied -4 to it. Same thing with 3/2. That's the same thing as 1.5. Same thing with -2. So we can do the same process here. So just for reference, I'm going to plot the points. This is a sine graph, but it's the same concept. You're just going to take whatever the amplitude is, multiply it to the y value of the original point. Okay? So let's do the first one. So this is 2 sine of x. So what am I going to be multiplying my points by? 2. So if the y value is 0, what's my new y value for the next graph? 0. The y value is 1. What's the new one? 2. Y value 0? -1? -2. And then guess what? Once you get the pattern, you just repeat it. So 0, 2, 0, -2, 0. Once you can get one period, it's just repeated patterns. So this is the first graph. So the black graph was sine of x. The orange graph is 2 sine of x. Okay, let's try the next one. So what am I going to multiply my y values by? 4. So at -2 pi. So the y value is at 0, so it's at 0. Okay, my original one's at 1 here, so my new one's going to be at 4. 0 is still 0. My original one's at -1, so my new one's going to be at -4. And then we're back at 0. And then it just repeats. So I have 4, 0, -4, 0. So then it looks like this. Okay. Walk me through the next one. So -3 sine of x. So what am I going to multiply my y values by? -3. So in other words, finding these points are really easy because literally the original graph's points, the parent function's graphs, is literally 0, some form of 0, -1, and 1. So it's really easy to multiply the amplitude too. So this first one will be what? 0. Then what? So this is 1. So my new one will be at -3. Back at 0. Then if this is -1 times -3, -1 times -3 is +3. Back at 0, and then it repeats. So -3, 0, 3, 0. No. Okay, last one. So negative 1/2 sign. So that means I'm multiplying my original y values by negative 1/2. So we know where this one's going to be 0. It's been for the last 3. If this is at 1, where's the new one? Negative 1/2. So it's like right here. Back to 0. And this is negative 1. Where's the new one? 1/2. So it's like right here. Back to 0. And then we repeat. So negative 1/2, 0, 1/2, 0. So it's actually a pretty smaller sound wave than the original. The other ones were bigger, but this one's smaller. And again, if that part confuses you, Desmos can help you with that. If you put it in steps of pi and things like that, that'll help you a lot. So, and I was bad at labeling my graphs, but this is 4 sine of x. This is negative 3 sine of x. And this last one is negative 1/2 sine of x. So again, what the amplitude does is that it controls how high and low the graph goes, the max and the min. So the way you find the amplitude is if you're given a sine of theta, or no, let's go x. So a sine of x equal to y, or you're given y equals a cosine of x. Amplitude is equal to the absolute value of a. Meaning, whatever that a value is, whether it's positive or negative, you're going to take the absolute value of it. So if you take the absolute value of a number, it's going to make that number what?
Wait, sorry, can you repeat it?
If you take the absolute value of any number, it always makes that number what? Positive. So in other words, if it was a negative a, it's still the amplitude would still be positive. Okay. So like for example, the amplitude of negative 1/2 sine of x would be 1/2. Because you take the absolute value of negative 1/2. All right. Now, I'm going to be doing some jumping around. So, let's go to the next one. So, now we're going to add another letter. And surprisingly, it's not B, it's C. Okay, so we just did the amplitude, that's the A. Now we're going to add another letter. I'm on page 21. All right. So I have y equals a sine of x plus c and y equals a cosine of x plus c. A does the same thing for both sine and cosines. That means C is also going to do the same thing. Now, a little bit of vocab. Any graph primarily comprised of either sine or cosine functions is known as a sinusoidal graph. Fancy word, just means sinusoidal. And it can be stretched vertically, as we saw in the last lesson. That comes from the amplitude. But you can also shift it up and down as well. So, here's what we're going to do. Okay. They gave us the parent function of the sine graphed here. You guys still got Desmos pulled up, right? I want you guys to type in this function right here. So sine of x plus 3. Make sure the plus 3 is on the outside of those parentheses. So I want you to type in sine of x plus 3. And we're going to sketch the graph. So give me the value of y when x is negative 2 pi. So when x is negative 2 pi, it's at 2? It shouldn't be. Sine of x plus 3. So at 2 pi, okay, I know what they're doing. Okay, so instead of 2 pi, we're going to start at 0. Because it's hard to kind of figure out where 2 pi, negative 2 pi is. But remember, if we can find the pattern, it just repeats. Okay, so we're going to start at 0 instead. So what's the y value at 0? So it's at 3, so up here. What is it at pi over 2? So click at pi over 2. What do you got? It's at 4. Now, judging from how this graph looks, where do you think this next point's going to go? Back to 1, so back to 3. Now, where does 3 pi over 2 go? You should be able to see that one on Desmos. Goes to 2. And then finally 2 pi, where do you think it's going to go back to? Right. So in other words, it should follow the same pattern as this graph down here. So if we go backwards, if I start at 0 and I go backwards, where would negative pi over 2 end up at? 2, then 3, then 4, then 3. So here's my graph. Here's my question. Did the amplitude change between the two graphs? So did it look like it's getting taller or thinner? No. The amplitude is both, for both of these graphs, what? They're the same, but what is it? A in this case is equal to, if there's nothing in front of it, what's the unspoken number? 1. So the amplitude for both those graphs is 1. Okay? Now, what actually happened to this purple graph? What did it do transformation-wise? So how did I get from the black graph to the purple graph? You went up what? 3. So that's how we got to the purple graph. We went up 3. So guess what? That's what this plus 3 controls. It also controls what we call our midline. Okay? So the midline is a great thing in sine and cosine graphs. It's basically that middle point that you're always going to hit. Okay, so in a sine and cosine graph, you got 3 important points. You got your max, you got your min, and you got your midline. Okay, so where would my midline be? Here. So in other words, what horizontal line would go through all of my middle points at y equals what? 0. So my midline would be right here for my original graph. So this is the midline at y equals 0. So we call it the midline. It's where, so you know how when we're making the sine cosine graphs, it's going to go from max to the middle to the min? The midline is where that middle is going to be, always. And it's nice because when we shift the graph up, that midline just shifts with it. So if we know where the midline is, we always know where our middle is. So if I go 3 up from 0, what will my midline be of the purple graph? Yeah, y equals 3. So here's the midline for the other graph. So this is the other midline, and it's at y equals 3. Okay, and let me ask you this. Where does the 3 and the 0 come from, do you think? Where do you see this 3 in the original function? The plus 3. Where do you think the 0 comes from the original function? Are we adding anything here? So technically we're adding, if we add nothing, we're technically adding 0. So if there's nothing being added to it, the midline is still at y equals 0. So your midline is always at y equals whatever the c value is. And again, it looks like this. So let's try another one. Now, here's what's great about the midline. Our amplitude is what? No, our amplitude for both of these are what? What value is being multiplied to the sine? 1. We already said our amplitude was 1. Well, is it 1 away from the max and min? Is it? So how many units is it from the max and the min? So of this graph, how many units is it from my max to my min? So if you go from here to here, how many units is that? Count, guys. 1, 2. There we go. 2. But how many units is my max from my midline? It's 1 unit. So if we go from midline to here, that's 1 unit. Oh, Lord. No. Also from the minimum, 1 unit. And it's the same thing here. So here's the max from the midline, still 1 unit. That's the amplitude. Max to min, or midline to min, 1 unit. And all of these come from the amplitude. So in other words, your amplitude is also the distance, the max and min are from the midline. So that helps us with the next one. So this time, they did not give us the parent function to look at, but we can figure this out. So first off, where would my midline be at? So what's my C value for this graph? It'll be at what? 1. So at y equals 1. So my midline is at y equals 1. So I'm going to go ahead and draw that line. Now, what is my amplitude? It's 2. So if I took the absolute value of 2, it's still 2. So A is equal to 2. So that means that my max and min I can figure out from counting 2 units from the midline on either side. Okay? So if my midline's at 1, what y value is my max at? So So count 2 units away up from the midline. So if I count 2 units up, where's my max? At 3. So my max is at y equals 3. So I'm actually going to graph that line. And you'll see why in a second. Okay, what about my min? If I count 2 down from the midline, what is it? So if I count 2 down from the midline, it's -1. Good. So y is equal to -1. So if I label everything, this is my max, my mid, and my min. And guess what? Every last one of the points that I'm about to graph will fall somewhere between those 3 lines. In other words, they're going to hit every one of those 3 lines. Okay, so now we know exactly where all my y values that we're about to graph are going to go. So let me ask you this. On a cosine graph, so look back at your graphs, look specifically at the y-axis. Did a cosine graph start at its max, its mid, or its min? So look at the parent function of the cosine graph. Where does it start? The max, the min, or its mid at the y-axis? It starts at the max. So if you look back here, okay, if I go back a couple, I'm going to go way back to the very beginning. Look at the pink graph. If I was to draw right here, this is the cosine graph. It starts at its max. That's always true for its cosine graph. It starts at its max unless it's a negative amplitude, then it starts at its min. And we'll get more into that for right now. But cosine starts at its max. So watch this. This is how you graph. We're going to start at the max. And then you just go down the line. So at my next x value, where would it go? The mid or the min? The mid. Then it'll go where? Then it will go where? Then it'll go where? If I go backwards, it'll go where? Mid. Then where? Then where? Then where? And look at that, we just graphed it. Didn't even have to have the parent function. So the equation of the horizontal line that the curve rises and falls 2 units above is the midline, which is at y equals 2. You always got to put not y equals 2, y equals 1, my bad. So you always got to put y equals and then whatever the c value is. If you don't put y equals, it's not an equation of a line. All right. Now what's the range of this graph? So what's my lowest? We kind of already found it. What's my lowest y value? -1. What's my highest? 3. So basically, if you find all 3 of these lines before you graph a trig function, it makes graphing it stupidly easy. All right, so curves that have the general form y equals a sine of x plus c or y equals a cosine of x plus c, the value of c is called the midline or the average value of the trigonometric function. So the height or horizontal line that the sinusoidal curve rises and falls above and below by a distance of the absolute value of a, which is the amplitude. So that's essentially what I was explaining right here. This is the amplitude. So both of these represent the amplitude. And that's the distance from the midline on either side of it. Okay? So whatever that amplitude is, you take the absolute value of it. That's how far up and down you go from each. All right? Now, there's a couple of things you also need to know. On the y-axis, so I always tell my students to start at the y-axis. Now, if you are graphing a sine function, so if you're graphing a sine function, you start at the midline. So your first point is going to be at the midline. If you have a cosine function where the a value is positive, you start at the max. And if you have a cosine function where the a is negative, you start at the min. So sine starts at the midline, always, regardless of if it's positive or negative. Cosine, if it has a positive a value, it starts at the max. If the cosine has a negative a value, it starts at the min, at the y-axis. So remember, all of this is based around the y-axis. That's where it's going to hit the y-axis. Okay? So, let's graph some graphs here. All right, so we're going to do the first one here. So it says to state the range. We'll do that in just a minute. Before I do that, where's my midline? So where's my midline at? Nope. Not just -2, but we have to put in front of it. Blank equals -2. Y equals -2. That's where my midline is. So your midline's always your C value. So my midline is at y equals -2, so I'm going to go ahead and graph it. So that's my mid. Now, what's my amplitude? So if I take the absolute value of my A value, that's my amplitude. What is it? 4. So I do that based off of this number right here. So that would be 4. So that's going to help me find my max and my min. So my max, what y value is my max at? So you want to go 4 up from the midline. So count 4 units up from the midline. So it's at y equals 2. So I'm going to go ahead and graph that as well. That's the max. My min. So if you go 4 down from the midline, it's at -6. So y equals -6 is the min. All right, now let's graph. First off, what type of graph is it, sine or cosine? It's a sine graph. So that means on the y-axis, which of these 3 lines is it going to start at? The max, the min, or the mid? The mid. So you start with the mid. Now it's positive. So am I going to go up next or down? Up. So I'm going to go up, mid, then where do I go? Down, back to mid. Then on the opposite side, do I go up or down? Down, mid, up, mid. So this right here is my graph. Okay? So what's my range? So it's basically the max, the min to the max. What's the min? To the max? 2.
What did you say? I didn't hear anything about it.
All right. Shh, shh, shh. Now let's do this cosine graph. So first off, we're going to find the midline. So where is my midline at based off of this cosine graph? Nope. It's whatever's being added or subtracted on the other side. It's the C value. So y equals 3. So I'm going to go ahead and graph that. So it's right here. Because y equals 3.
Oh, sorry. I was, the midline, I was counting 3 up from that.
Different graph.
Yeah.
Okay, what's the amplitude? Remember, take the absolute value of whatever the A value is. It's 2. So that means I'm going to go 2 up from the midline, 2 down from the midline. So where would the max be? Y equals 5. Good. 2 up from 3 is 5. So there's the max. Where's the min? 1. So it's 2 down from the midline. So right here. Now this was on your test. I'm not going to make you graph 2 graphs on 1 graph.
Okay.
We'll do somewhere just singular later.
I'm sorry. But
Yeah.
This is like
You'll see it with 1 graph in a minute, but this is just for right now. Okay, so it's a cosine graph, and the A value is negative. So is it going to start the max, the mid, or the min? The min. Where's it going to go next? The mid, then the max, mid, min. Opposite way, mid, max, mid, min. So there's that graph. Okay, what's the range? Backwards, 1 to 5. It's always in numerical order. Okay, we're going to call it quits for today. We'll do some more with it on Monday. Okay. Now, so I'm going to give you guys 5 minutes to study for the unit circle. So 5 minutes to study for the unit circle quiz, and I'm taking it down a minute. So it says 7 minutes and 6. So if someone's crashed behind you or next to you, wake them up. So you got 5 minutes. I am moving on at 12. Well, it's actually more like 3 minutes. It's 12:55. The unit circle next to you. The next unit circle quiz. So remember what I said? You guys take it every day, but I'll take the high score. And you get 100, you don't have to take it again. So if you did get 100 on the one yesterday, you're good.